Hello over there. Good morning, good afternoon, good evening, my dear students. This is your one and only AG sir. This is my number, and today we are here again with NLM series, and this is the last lecture of exercise 1. Today we are going to discuss pseudo force weighing machine. Okay, today is the last lecture of exercise 1. From the next day we will discuss the exercise 2. Okay, the question number 1 is the lift is going up. Total mass of the lift is 1500 kg. Sorry for that. The variation in the speed of the lift is given, and the acceleration at the time 11 second. The tension is what? First of all, I want to know the acceleration, and from here can I know the acceleration is delta v by delta t. Change in the velocity at 10th second the velocity is 3.6 and 12th second that is 0, so change in velocity is 3.6, and for this change the time taken is 2 seconds. So acceleration is 1.8 meter per second square, and as I can see from the graph, the lift is retarding. This is retarded motion, and for the retarded motion I know the tension T is equals to m into g minus a. If the lift is going upward, then the equation will become g plus, and if the lift is retarded, the acceleration in downward direction, then the equation becomes m into g minus a. The mass is 1500, g is 9.8 minus 1.8, so this is 1500 into 8. So answer is 12,000 Newton. This much tension is acting. Okay. Then the next question is, here we have a man of mass 50 kg standing on a light weighing machine kept in the box 30 kg. The mass of this outer box is 30 kg and mass of the man itself is 50 kg. The box is hanging from a pulley fixed to the ceiling through the rope. In order to the man is applying force such a way that the system remains in equilibrium. If the system is remain in equilibrium, means the man mg, tension, and the normal. This is the FBD of man. For the box, this must be tension, this must be its own mg, and this must be normal. Am I clear from these two figures? Again I am pointing out in the figure that this is tension on man, this is direction of mg, and this is the normal applied by the box. For the box I am changing the color. For the box, normal is in this direction, tension is in this direction, and its own mg. Okay, so man, normal, tension, mg. So here we can write n plus t equals to mg. And for the block, its own mg, normal, tension. So from here we can write t is equals to n plus mg. So here we can write t minus n equals to capital mg. T minus n equals to capital mg. Adding both the equation, n and n is gone, so 2t is equals to capital M plus small m into g. So the tension must be T is equals to capital M plus small m, 30 plus 50 kg into 10 by 2. So this is 80 into 10 100 800 by 2, answer is 400. So tension must be of 400 Newton, then only the system will remain in equilibrium. So tension will be 400, but tension is not asked. What is asked is the weight shown by the weighing machine. What is the weight shown? Weight shown is N. Weight shown is N. And what is N? If the tension is 400 Newton, then let us find out what is N. Then I can write T minus mg equals to N. Tension is 400 minus mass is 30, g is 10, is equals to N, and N comes out as 100 Newton. So what is the reading of weighing machine? Reading of weighing machine is 100 Newton. Okay, the next question is, here we have acceleration A. System is moving upward, and mass m exerts a force of 7 mg by 4 on the floor. So this is the concept of apparent weight. What is that? That is m into g plus a when the lift is going upward, and that shows 7 mg by 4. So from here we can find out what is A. Let me solve. M into g plus a is equals to 7 mg by 4. M and m is gone. So acceleration is equals to 7g by 4 minus g is equals to 7g minus 4g by 4, and total is 3g by 4. Acceleration is upward, definitely upward. Then we have a block of mass capital M. Angles are 30, 60, 90, and the angle of 30 and 90 is on the horizontal smooth surface. So we have something like this. (30°), 90° on the floor, and this is 60°. And cubical block of mass small m is over here on the line 60-30° triangular block. Okay, what is the horizontal acceleration of capital M must have related to stationary table so that it remains stationary with respect to triangular block. Okay, this is capital M, this is a small m, and they have asked that the acceleration of capital M so that it remains at rest with respect to small m. This type of question we have done before, and let me consider that the acceleration is in this direction. So acceleration felt by the small m is in this direction. This is a pseudo acceleration, this is a g, and as we know that the components along the surfaces are, this is g sine 30 and this is a cos 30, and from here we can compare a is equals to g tan 30. G is 10 and tan 30 is 1 upon root 3. So answer is 10 upon root 3. Simplify the equation and you will get the answer. Whatever it is, use your calculator, use your mind, and you will get the answer. What is the correct answer is. Okay. And the next question is, here we have again some sort of system. We have two blocks, mass m1, m2, and m1 is greater than m2, which means the system is going in this direction with acceleration a. This part is going upward with acceleration a, and this thing is sliding rightwards with acceleration a. The spring balance is in between. What is the spring reading of spring balance? Okay, not to worry about. Very easy question. First of all, This is spring balance M1, this is M2. My figure is not so good. Here we will have M1G. Here we will have tension and acceleration is in this direction. Here we will have tension, here we will have M2G, and here we will have acceleration. Writing two equations and adding both of them. First equation for this part is M1G minus T equals to M1A, and next one is for the other T minus M2G equals to M2A. Tension, so the M1 minus M2 into G upon M1 plus M2 equals to A. This is the acceleration. What is the reading of spring balance? That will be the tension. So what will be the tension? For tension we are using this equation and putting the value of A. Equation was M1G minus T equals to M1A, and the tension is M1 into G minus A, and the acceleration was, if you are aware, upon M1 plus M2. Putting the value over here, T equals to M1 into the bracket G minus M1 minus M2 upon M1 plus M2 into G. Taking the G common, M1 G 1 minus M1 minus M2 upon M1 plus M2, and our final answer will come out as 2 M1 M2 G upon M1 plus M2. This is the tension. This is the reading of spring balance. The reading of spring balance is 2 M1 M2 G upon M1 plus M2. The next question is, the acceleration is in this direction. What is the minimum value of A so that the capital M falls freely? This question we have done before in previous classes. This is the acceleration of the system. So the pseudo acceleration experienced by the system is in this direction. This is G, this is G cos theta, this is A sin theta, and for free fall the normal must be 0. So we can write G cos theta equals to A sin theta, and from here A is equals to G cot theta. Acceleration is G cot theta. Next is this. The reading of weighing machine is, okay, for 2 kg block this must be 20 Newton, this must be 20 cos 30, and this is 20 sin 30, and 20 sin 30 will act in this direction. So there is no meaning of the components parallel to the surface. The only reliable component is 20 cos 30, and this is normal. So normal is the reading read by the weighing machine, that is 20 cos 30. So answer comes out as 20 into root 3 by 2. So every weighing machine, each, this one and this one, each weighing machine reads 10 root 3 newtons. Okay, this much is enough for today. Thank you. Thanks for watching. See you in the next class.